We're going on to topic 9, mini lecture of section 1, composite functions and inverse functions. Now, in this mini lesson, we're going to go over these objectives, but this may be an area you would need more review on. So I'm going to strongly suggest that you look at the textbook lesson that I give on this, because those lessons are like, I divided this into 2 parts, and it's almost 50 minutes going over background for this. So hopefully you would have done that or will do that to give you background so you are really solid in this particular area. But we'll do what we do and review and bring in a number of other things. So to start us off, we're going to take a look at what they're saying here. For each pair of functions, find f composed with g with the value of 1, and then g composed with f with the value of 1. And there's other ways to read this too. F circle G, G circle F. And basically what we're doing here is we're going to take these functions where this is the function of f and this is the function of g, and we're going to sort of combine these functions, taking this as our x value and putting it there. And I'll be going over this in some detail. And then we're going to take this as our x function and putting it there. We're sort of saying that this happens first, we're going to then put it in the other, and then come up with a calculation. And I think the best way to do that would be to very carefully go through an example with you. So we're going to do this one first, and I'll write it down here. Now this looks like fog, but it's F composed with G. So we're saying that we want to put a 1 there. So let me write these out too. So in this first one, we're saying we're going to look at G. This is the function of G. And we're saying that x is going to equal 1. So right there, we're going to put the 1 there. Square it, and then minus 4. So 1 squared is 1, minus 4 is 3. So this becomes a negative 3, a negative 3. We're now going to take this negative 3 and bring it into this function. 2 times negative 3 will be a negative 6. So for the first part of this, where we're taking this 1, putting it where the x is, getting a negative 3, and then 2 times negative 3 is 6. For this one, it's going to be a negative 6. And that's the answer. Now what we're going to do, and I've erased this down here so we can put our work here. We're going to use this 1, but put it in our f value first. So this 1 goes right there. So 2 times 1 is going to equal 2. Now, once we get our 2, we then go into this, and we go 2 squared is 4. 4 minus 4 is 0. So for this one, when we do G composed with F, or G circle F, where we're using a 1 for our X, we end up with a 0. And this is how we do it. Now another composite function they often do is just use the X instead of the 1. So let's do that. So first with G. So our X is going to be this. This is our X. So we bring our X over here. This is our X value. We bring that to our F function. Put the X value, this value, right there. And it becomes 2 times that, which will be 2x squared minus 8. So for this one, it's 2x squared minus 8. Now, we're going to do the opposite. We're going to take our x value from the f first and put that into this where the x is. And this becomes then 2x, replacing this x with what we're saying our f of x is, this. And now we square that and get 4x squared, and then we add the minus 4. So this one becomes 4x squared minus 4. And if you check these out, these are our answers below. Now, when I first looked at this some time back, it was a little mysterious, but since I had gone through the textbook material, where it went over these in some detail, reviewing the terminology for this, it's sinking in. And this is what we call study. You will study these to eventually understand what's going on. And hopefully this video is going to help you do that. And part of it will be if we can do letter B. So let's look at letter B. Now we're doing basically the same items up here, but now we're using this function and this function for G. So starting us off, we're going to do first f of G, or f circle G, or f composite G, where we're going to put a 1 in our value over here. So if x is 1, 2 times 1 is 2, minus 1, this is going to equal a 1. So 2 times 1 is 2, minus 1 is 1. We now take the value from our g function and bring it into our f function. So x is going to be 1. There's our 1 right there. 1 plus 4, I'm sorry, 1 plus 3 is 4, and the square root of 4 is going to be 2. So for B, this is going to be a 2. And let me erase this calculation now, because it changes as we do this one. We're going to say F first. Well, now here, we're going to put our 1 here, and this is 1 plus 3 is still 4. The square root of 4 is 2. So our x value from this function now goes into here. So this becomes 2 times 2 is 4. 4 minus 1 will be 3. So when we take the f function first, put our 1 in there, get a value, bring that to our g function, put it in there, and we get 3. Now in this next one, we're going to use x instead of 1. So we're going to do our g function first. This is our x value. So we're going to take this, put it in the f function. Where the x is, we're going to replace it with this right there. Give you a moment to write your notes. And now we have 2x minus 1 plus 3, which will become 2x, joining these, plus 2. So this one here becomes the square root of 2x plus 2. All right, let's set the next one up. Now here we're going to take our f function first, and this is what x is, and we're going to put it in there. So it's sort of the opposite here, where the x is. So it's going to be 2, and then we take the square root of this, and then minus 1. So we're taking this x value and putting it where the x is over here. So this just goes right where the x is. This is where our x was. So this then is 2, the square root of x plus 3 minus 1. And be careful not to put that minus 1 under the radical sign. There might be a tendency for that, but don't. And you have to be sure you put the 3 under there. Okay, so there's A and B. Now, as we look at C, this is often what they use to indicate a composition. They'll use the letter H as a function letter. H of x is this. Now here they want you to brainstorm, and in the additional exercises I go through a lot of these, and a lot of these too. So again, this is our mini lecture, kind of reviewing the topic. If you need more work, you know where to go to find it. There's plenty of reference out there, and of course your textbook is your major reference. So, what could have been the function of x, f of x, and the function g of x that will give us this composition? And there's hard ways to do it, and there's easy ways to do it. So let's study it for a moment here. And see if you could go along with this. If your f function was the fifth root of x, and your g function was 3x minus 7, if you had f composed with g, this is what you would get. Because you would take this, put it where the x is, and that's what you would end up with. And that's sort of what they're showing you is going on here. And that's what we did for all of these. And then you're going to be trying it out in your practice and quiz me. Let's go on to topic 2, which is determine whether a function, which is this, is one-to-one and thus has an inverse that is a function. Again, lots of background to this. I'll try to explain it in this short way, but again, in your textbook, they go over this in great detail. Now, first we have to graph this. Well, I was playing around with my computer and I was looking for graph paper. Well, I actually found this free graphing calculator online. Now, if we take what they give us for example 2, which was f of x equals the square root of x. A way to put that in a graphing calculator, and this is some of the tools they're giving us here, is to say we convert this to y. F of x could be y, and that's what I put there in my first calculation, equals, and what did we say from chapter 7 was another way to write this? Because I didn't see a square root sign here. We said this is actually x to the 1/2 power. That's the square root of x. So how do I put that in my calculator? Well, I said we had to use a caret sign, which they do have here. Here's the caret sign. And then put this in parentheses to the 1/2 power. And that's what I did. Okay, because now what I'm going to do is graph that. So we'll see what the graph looks like. And there's our graph. Wow. See, that's a beautiful graph. I was going to do a lousy sketch of one. Now, from previous lessons, we have said that if we make a vertical line like so, and take this vertical line and move it across the face of our graph, does this vertical line intersect this graph in more than one place at a time? And the answer is no. So we say it passes the vertical line test, and this is a function. Now, if we take a line, and I'll make this one green, and what sort of line is that? Well, that is a horizontal line that I'm going to move over the face of my graph. Does it intersect this graph as it moves horizontally down more than one place? And the answer is no. So we say it passes the horizontal line test. Now, if it's a function this way and passes the vertical line test this way, we say it is a 1-to-1 relationship. That is, this function has an inverse. And we'll be doing some inverses here shortly. But for number 2, it says determine whether the function, and that is in its graphic form, which is f of x is equal to the square root of x, this function that we converted to y, put this in a graphing calculator. This is the graph of it, and through this process we determine that it passes the horizontal line test, this one, as well as the vertical. It is a 1-to-1 and therefore has an inverse. Again, lots of stuff going on here. Now, you're going to be able to keep your booklets open and see these, and I will keep my booklet open too. But for number 3, we are to determine whether each function is 1-to-1, and if it is 1-to-1, find the formula of its inverse. This is the inverse symbolism. F with a -1, this is not a negative exponent. It's not a negative, it's just the symbol for the inverse function. And this is read F inverse. Say it with me. F inverse of x. And I'm going to show you in great detail how we get to that. But first, I'm going to graph each of these to determine if it's 1-to-1. So you remember what they are. So there's my first formula. I've converted it from function into y equals x minus 3. And now I'm going to graph it. So there's the graph. Again, I was going to sketch these. This is beautiful. Does it pass the horizontal line test? Yes. Does it pass the vertical line test first and the horizontal? So this is a 1-to-1 and therefore has an inverse. And I'll be careful to say this correctly. So We replace the f of x with a y, and then equals 4x plus 7. I know it's a little tiny, but let's graph it now. And there's our graph. Now, the vertical line test, does it pass it? Yes. Remember, they're saying that these are a function. We're wondering if it's a one-to-one relationship. Well, in order for that to be true, it has to pass the horizontal line test. Does this pass the horizontal line test? Yes. So this has an inverse. So far A and B has an inverse. So letter C, again we converted it from function to a y equals x caret 2, that's x squared plus 1. Now this one is a parabola, and again I was going to try to draw it. This is great. Now it passes the vertical line test, only intersects one place, but does this parabola pass the horizontal line test? And the answer is no. It intersects there and there. So this does not have an inverse. So the only ones we have to concern ourselves with are the A and B. And we'll get back to that right now. So there's our A. This is a function and has a one-to-one. So now we can find what is called the inverse. Now in your textbook there is a series of steps that we use to find the inverse. So we'll write it out in detail and take some notes on this, and then you can review it in your textbook. Now we saw the graph of this. We want to find its inverse. Well, step one to find the inverse is we convert the function notation to a y. And that's what we were doing when we made a graph of it. Now, the second step is to exchange the y with the x. And now we solve for the letter y. And now we convert the y back to the inverse function. And that's really how easy it is. So this was our original. And what did I do here? I think I put a 1 there where it should have been a 3. Sorry about that. All we have to do is change our 3's here. There we go. If it were a 1, then that would have been correct. But it's a -3. So everything is the same, except we have to have a 3 there. That's much better. And if we look at our answer key, that is supported again. Watch your numbers and check your work. You had everything right, but the wrong number. All right, let's go on. Okay, let's do this one correctly here. F of x equals 4x plus 7. We change this to y. We exchange the x and the y. The x goes there. The y goes there. We solve for y. and we divide everything by 4. Then we convert this back to inverse function notation, and we get x minus 7 over 4. And that is good. Now the way they write it in the book, which is the way I would write it too, is 1/4 x minus 7/4. That would be the way to write it. Because if they ask you to graph it, this is a very easy way to graph it if you know how to graph it using your slope-intercept form. Here it's be a little confusing. Okay, now this one is not a one-to-one relation, so we cannot graph that. We cannot find an inverse of it. And I'm looking at this next one already. So, okay. Now, they want us to graph this and its inverse on the same set of axes. Well, we have our little tool, don't we? But first we have to find its inverse. And it does have an inverse. It's 1-to-1. So it's going to be y equals a negative 3x plus 6. This then becomes x equals a negative 3y plus 6. So we switch the x and the y as part of our recipe. I'm going to move the y over here to make it positive. The x goes over here and it becomes negative x plus 6. So I'm just taking this term now, moving it over to this side to make it positive. Now I'm going to divide everything by 3. And I get now I'm going to put it in inverse form already. F inverse is a negative 1/3 x plus 2. So remember, we're going to graph this, and we're going to graph this. So I'm back to my graphing calculator. There is my first equation. There is my second equation. Let's see how it works. And there are my graphs. Wow. Now, an interesting thing that I point out in my other lecture is that there is an axis here that runs right through there. This is your axis of symmetry. And note that this is often a dotted line or a dashed line, our axis of symmetry. And that if you were to fold this paper, if it were a paper, at this axis of symmetry, that this and this are reflections of each other. That is what we call the inverse. That our first line, which was this one here, that's our first equation. This is the inverse over here. So this is the inverse. And this is our regular. Okay, so again, a technique that they may ask you to do that we'll be doing, and I'm glad we have discovered this. Well, for number 5, they say use composition to show that this and this is the inverse of that. So we're going to convert this to y equals the third root of x plus 3. And now what we're going to do is reverse our letters. It's going to be x is equal to the third root of y plus 3. And now we want to solve for y. Well, how do we solve for y? We got to get y out of that radical sign. And from chapter 7, we said we did that by raising this to the power of the index, which is 3. We do it to one side, we do it to the other. So this becomes x to the third equals y plus 3. That is the radicand. Raising something to its index number power, you just get the radicand. And now we solve for y. And we get x to the third minus 3. And lo and behold, when we convert that back to its sign there, its inverse function sign, we get that. Okay. Well, we finished. We kept it under 37 minutes. Lots of good stuff here, but again, you're going to need to get more background on this. You do so by reading the textbook or watching our video. And good luck on your Section 9 study plan.